Hello everyone, myself Venu, lecturer in mechanical engineering from Government Polytechnic Warangal, and I'm dealing the subject refrigeration and air conditioning. And today's topic or lesson is on dust collectors and air distribution system. So if you observe the last previous video session of mine, this subject regarding R&AC, we have seen air filters regarding that, and some dust collectors we will discuss in today's session. So just we see the objectives in the today's video lesson. So after completion you can understood what are the bed filters and electronic air filters, the cyclone air cleaner, the centrifugal dust collectors, electronic air filter, and air distribution system. So you will see here all these topics in this today's video session. In the last previous we have seen some dry filters, and we have seen other type of the air filters we have seen in that sub classifications we have seen that, and continuation we will see the wet filters and electronic air filter, cyclone air cleaners. So how you can see the line diagram of them and how they are different from the previous cases. Just we move into the wet filters now. Wet air filters, here you can observe the diagram of that wet air filters. So observe for a meanwhile that you can understood it's very simple. Just if you know the diagram, how the process is happening, just you can see this line diagram and you can observe very easily. You can understood what is happening in this case. Okay, so hope you'll see the what are the components out there in this wet air filter. So its name itself is indicating we are using some liquid or water here to make it as a wet functioning of this air filter. So you can see one side of a passage where the dirty air or the air which is containing some the dust particles or some dirt particles, so it is entering through this passage, and exit you can see at the last where further the eliminators are provided. So before the air is passing into the next onto the cooling coils, the clean air is there here where it is passing over the cooling coils or evaporator coils. Now you can see in between these two passages or arrangements, you can see a water from pump, the pipeline. You can see here water is coming through these different pipelines. So where it is connected to the spray nozzles, the water is spraying here. So where it is making contact with the dirty air or the air with the dust, so you can see the water sump is placed at the bottom. So all the dust with along with that water particle will again collect at the bottom, that is at the water sump. So we will see a few lines regarding this explanation of wet air filters. Right, absorbs the soluble gases present in air. So for example, if you see the previous cases, that is dry filters and viscous filters, so in those two cases the combination of both the things is not happened, like removal of dust particles and gases which is present in the air, they are simultaneously they are not removed there. But whereas in this wet air filter, so the simultaneous action on both the things will happen, the removal of the dirt as well as the gases which are present in the air, so they can also be eliminated in this wet air filter. So mostly it absorbs the soluble gases present in the air, and it is a combination, as already told, it's a combination of the dry and viscous filters, and used to remove the dust and gases. So both these things it can be removed, and these are very much more useful than the dry filter and viscous filter. Why? Because the combination effect is doing by these wet air filters. Next, the combination filters remove the dust and gases from air. So air is made wet by water spray. So as already told, whatever the dirt along with the air is coming here, it makes contact with the water, what happens here, as the dust particles or when it mixes with the water, it gains more weight. Additional weight is added along with the water and the dust particles. They gain more, and they fall down in the water sump. You can, where the water sump is provided at the bottom. So due to its additional weight gained by the dust particles along with the water, it will come and fall in the water sump. And the effectiveness of washer depends on wet ability of dust by water spray. So here also one criteria, that whatever the dust particles coming along with that air, so it has to absorb the water, and due to its absorbness, what happens, it will readily absorb the water, and it will collect at the bottom. If they are not having the wet ability, it means if they are not absorbing the water content, so it is a waste of using these wet air filters. Maybe efficient, maybe not efficient for that particular type of the dust particles. If they are present in more the quantity, if they are not absorbing the wet nature, so it is a waste of using these wet air filters. But effectively it will work under all the conditions, mostly used in the industrial area where the dust and gases or smoke is present. So that is regarding the air filter, what you are using, that wet type of air filters. Okay. And more advanced the air filter, which is mostly used in the industries where the bigger appliances or larger appliances are there. So there we can use these type of air filters, electronic type of air filter, where the lot of the dust particles can be removed by this electronic air filter. So just have a look regarding this the diagram what you are seeing here. You can see the diagram. So observe the arrangement, how it is made. So electronic air filters, so there is a positive charged and negative charged things are there. You can see how the dust particles are moving. The path you can see from left towards the right, they are moving, and there are electrical connections in between that. And the plate whatever there, it is grounded plates are there here. It's connected to the ground, and a grounded tube is there. And the whatever the dashed lines are there, so they may be taken as a, just like they are positively positively charged, or high voltage supply is given to that, whatever all the positive placed lines. And the dust particles, you can observe here, it is collecting at the negatively charged plate which is there here. So high voltage wire is provided here, where it is supplied to that positive high voltage supply, and other high voltage wire is there which is connected to the grounded tubes. So airflow will take place from the left side. So let us observe what is happening in this electronic air filter. Right. So here it is also known as the electrostatic air filters. Electrostatic air filter, because it works on the principle of the electrostatic, where the static electricity is static nature of electricity is it can be seen in this system or in this air filter, where it is readily absorbed whatever the negatively charged dust particles, it will be absorbed by the positively charged, like uneven like unliked charges are there, they will attract each other. Unlike electrical charges attract each other. Now the dirty stream of air passes in between one row of charged and ground plates. So what a charged plate is there, charged row, and other one is the ground plate. So in between that, whenever the dirty stream of air is passes, so it will be attracted towards the whatever the negatively charged plate is there, will be attracted to the plates. Now the plates charged to DC potential of 8 to 12 kilovolts. So intermediate plates whatever present in between them, so they are charged to 6.5 kilovolts. So dust particles charged and attracted in intermediate plates. So you can see the intermediate plates provided here. So they can readily absorb the whenever they get charged, they will attract to the some unlike body whatever is there here, that to that plate, so that these dust particles are attracted here. Now uh, so they are most efficient in larger installations. So collector plates of a filter coated with oil to catch dust particles. So there are collector plates here, so where it is additionally what we are doing, they are provided with the oil. So whenever they the charged particle, they will attract readily to that another intermediate plates, as well as they are provided with some oil to catch the dust particles readily. So these are periodically cleaned due to attraction of the dust particles after some usage. What happens, the film, the dirt film will be provided on that plates, so they can be periodically cleaned after usage. So this is regarding the electrostatic air filter. It's a very important topic. Or the electronic air filter, mostly which are used at the industrial sites where the bigger appliances are there. Okay, so that is about the second topic in this today's session. Next, so hope you are getting the topics regarding these air filters. Similarly, we will see another the air cleaners, named as air cleaner, which functions on the cyclone principle. That is a cyclone air cleaner. So just have a look regarding the diagram. So just observe for some time, and you can get some idea regarding this, the cyclone air cleaner. Okay, so hope you can see all these uh, the components involved in the cyclone air cleaner. As you can see the structure of that whatever the air cleaner is seen there, they will provide when there is some circular motion is provided in that particular in that air cleaner. You can see some cyclone type of a the movement can be seen in this air cleaner, where you can see air and dust inlet you can see at the sides. So this is a complete body, around the complete body, and the outlet you can see at the top. So there is a canopy at the top, and air outlets are provided at the top. You can see there will be a gaps provided in between that, so the air outlet will be taken place there. And here you can see some adjustable disc at the center, and where it is hanging the disc, and this is a cone type of structure, and whatever the dust taken out, they can be cleaned out through the bottom of that section. So just we'll see a few sentences regarding that. So these type of cyclone air cleaners are also used in the industrial side. So it is an industrial air cleaner and removes large particles. So mostly when the requirement is to remove the very dirt, or when the air contains more the sand or dust particles, so we can employ these type of air cleaner, cyclone air cleaner. So dirty air enters the body tangentially. So you can see where it is entering at the top, it enters the tangentially, so to that section whatever there, it enters the tangentially to the chamber. Now uh, the air entry velocity is taken here, generally when it ranges from 500 to 1000 meters per minute. So this is a requirement, so we can employ these cyclone air cleaners. So velocity ranges, remember this point, 5 to 1000 meters per minute. So due to centrifugal force in the reversal of direction of airflow, due to centrifugal force, that means due to this rotational force and the reversal of the direction of airflow, so as it escape from the unit, affects the removal of airborne dry solids. So addition of water sprays separates the moisture sticky particles. So to avoid the movement or to escaping of the dust particles, so addition the spray waters can be additionally provided here, where it separates the that sticky particles, all those things. So but wetted cyclones more effective, but operating cost is higher. So compared to that, so whenever adding some water sprays to that, it is more effectively it will works, but operating cost is very high compared to the normal cyclone air cleaners. Okay, so this is regarding the air washer. Next one is the air washer. You can see here the two passages again where the filtering is taking place, or the eliminators are provided here. So air inlet and air outlet is provided. So eliminators are provided for additional functioning of that air washer. It means whenever only the air has to be sent outside, pure air, it contains due to addition of the water particles, it will contain some moisture contents. So that water particles has to be removed with the help of these eliminators. So you can see at the bottom there is a pump, a heater, some makeup water is provided into the tank. So due to at every time it is making the from the top, you can see that water is spraying here at every time whenever it is doing. So due to making contact with the air, so there is a process of evaporation may take place at some time. Okay, so due to that, additional makeup water is added here. And if you observe here, so this air washer will also use as a air cleaners. So why you are studying in this topic? So it serves as air cleaner, and it acts as a humidifier or dehumidifier based on the condition. So the requirement, so when the requirement depending on the season effect, if the humidified air is required, so addition of moisture will take place here. So you can see here, so heater is provided, so depending on the season condition. So dehumidifier is also placed here. Okay, so it removes the dust and the dirt particles effectively. Why? Because the water particles are making contact with that, so effectively dust particle will absorb the water content and it will fall down with due to its heavy weight, and only the fresh air can be sent outside through the eliminators. For example, in these air washers, this type of arrangement, the fine soot, it means a very a micron particle of a dust cannot be removed in these air washers. There is a chance of escaping of that soot particles, very fine soot particles. What it is doing here, due to the spray headers, it breaks the water into the fine particles, and the combination of water wetted surfaces and water discharged from the spray nozzles. So here you can observe there will be wetted surfaces around this wall, and the water which is discharging through the spray headers. So both will combinedly will act on the dust particles. So it will effectively work on this to remove the dust particles from the air. Okay, and the surfaces continuously wetted here. So whatever can be passed through the surfaces also, so they can be continuously wetted. So eliminators plates minimize the loss of water droplets. As I already told, it contains some water droplets, water vapors, so where it has to be removed, and only the air has to be sent outside of that passage. Okay, so that is regarding that. Next, coming to the centrifugal dust collectors. So just like a cyclone dust collector, so here also the centrifugal dust collector, where the principle used in this is a centrifugal force. So you can just observe the diagram for a meanwhile. Next we will continue this topic. Okay, just we go through the components used in this centrifugal dust collector. Very similar to cyclone type, but here a little difference here. Components used in this is a different one. So you can see at the left side where the outdoor air is entering through the pipe, and you can see at the bottom, after it is collecting, a blower is placed at the bottom to suck the air, and next it will send that high pressurized air into the conical type of section which is provided here, where the whirling motion of that due to the blower, it will revolves here. Due to that rotation, what happens here, the whirling motion which take place in this conical this section, dust particles will collect at the sides of that system, the dust collector. Only the fresh air or clean air will pass through the tubes, and it will be sent through other passages, and dust removal can take place at the bottom portion here. Okay, So we'll see the few lines regarding this centrifugal dust collector. So they are popular in industrial applications. They are most popular in industrial applications. Effectively removes the large dust particles. When if you want to remove the large dust particles in the industry sites, they may be most popularly used centrifugal dust collector. So certain type of dust, like for example, if you have like ash, asbestos dust, or reused in industrial areas. So here these type of dust can also be removed in these centrifugal dust collector. So they may be used as application, or maybe the centrifugal dust collectors are used in the industrial applications. Okay, next. So here explaining this thing, so air stream pass into the conical chamber. You can see there is a pipeline where the outdoor air from the atmosphere is entered into this conical chamber by blower. First it enters with the help of a blower, it will be sent to the conical chamber here. Because of high pressure whirling air currents, okay, because of that high pressure whirling air currents, heavier dust particles are thrown to the sides of the valve. So due to its the action created due to the whirling motion, because the blower is giving out its high pressure, air is sent through that conical chamber. Heavy particles are settled at the sides of the wall of the chamber. So this is done in this centrifugal dust collector. So where collected at the bottom of the cleaner, at the bottom of the cleaner, the clean and the dust free air goes out from the top of the cleaner. So here what is happening here, the dust is collected at the bottom of the cleaner after settling down, after losing its whirling motion. It may be collected at the bottom, and the clean and the dust free air will goes through this. At the center you can see it will be moved top, and again it will be used as a clean air, so which will be sent to the further over onto the cooling coil or onto the evaporator coil. So not able to remove minute dust particles, so as it can be removing very larger particles like ash or some asbestos particles. So the very minute particles which are present, they cannot be removed in this centrifugal dust collector. So however it may be, so it is doing its function and may be used in this industrial application for a very effective purpose. And here to operate the blower and to create that much of high pressures, and to remove that very high large dust particles in this, it requires very large amount of power. It may, this cost of that equipment may also increases, but they may be used in these industrial applications also. Okay, so this is regarding the centrifugal dust collector. Next, moving on to the next topic. So hope you have understood these air cleaners, collectors, dust collectors, like that. And next topic is regarding the air distribution system. So this will also plays very major role in the air conditioning topic. Air distribution is also the requirement. How the air distribution has to take place, with how much velocity the air has to get distributed, and the air has to be distributed from the top, or from the bottom, or the upward airflow has to be taken, or downward flow has to be taken. So all these things can be analyzed in this air distribution system. Now, so if you see the sentences here, the AC plants supply air at a temperature and velocity so different from those required in different rooms. So at required temperature and at required velocity, so which is required for different rooms, so these AC plants will supply these conditioned air. Now these comfort conditions depend on acceptable effective temperatures. So what we have seen, the effective temperature, so it will depends on the different factors like dry bulb temperature, wet bulb temperature, relative humidity. So depending on all those conditions, these comfort conditions will depends. Okay. Next, the good air distribution, this is also one main factor where it is achieved by the proper temperature, humidity, the air motion in the conditioned space. So all these factors will also have the will have to additionally support to this for good air distribution. The variation in the temperature in the occupied space should not be more than 2 degrees centigrade. The air distribution is uneven, so there may be a changes of these temperature which affects the change in temperature. The designed air movement ranges from 7.5 meters per minute to 20 meters per minute. So desired air movement ranges from 7.5 meters per minute to 20 meters per minute. And here the effective direction is towards the faces of occupants. So for mostly whenever the occupants faces are there, so direction may be in that way. So whatever the sitting direction will be there, the occupants face direction should be the effective direction where the air distribution has to take place. Now see, we will just observe the schematic, the flow diagram of an AC system where the air distribution is taking place. So observe the diagram for a meanwhile, and you will get some idea regarding how the distribution of different airs is taking place. You can see the left side how the air distribution is taking place. The fresh air through the duct, through other duct is entering through the dampers here, dampers provided, then it enters and mixes with the return air which is coming from the return duct, which is used already in the conditioned space. So this is a return duct along with the dampers, and it mixes with the fresh air again, then it passes through the air filters. After the air filters, then again whatever the air is there, when it passes through the dampers after filtering, so pass through the dampers where it provides the direction to that, and here it enters through the AC equipment here. So there is a supply duct here where you can see whatever the used air is there. First the supply air, the conditioned air is after entering, whatever the used air is there, through that again it sends to the true atmospheric room here, where it enters into the return duct. Return duct is used to give the passage, and it enters into the again the starting of the equipment where it passes through the filters. Next, so the downward airflow is better than the upward airflow. So mostly chosen and more comfortable one is whenever the airflow which is coming into the conditioned space, if it is a downward airflow, it is much better than the upward airflow. And now what are the conditioned air? It's supplied to the rooms through grills. So grills are provided. So from that the conditioned air is supplied to the rooms. And here coming to the classification of air distribution systems. So several methods of air distribution systems used for different purposes mainly. So different air distribution systems are utilized here. So in that we will see some of them. So just we will list out all them. The main three are ejector system, the downward system, upward system. So in this today's class we will learn regarding this ejector type of air distribution system. So in that we will see again the subtypes, and we will discuss on that what is the ejector air distribution system. Okay, so starting from the ejector system. So in that also the ejector system, so different arrangements can be made in this ejector type of system. One is a simple ejector system, pan type ejector system, combined pan ejects for supply of return air, and comfort draft system. So all these four are different arrangements of the ejector system. So first we will see the simple ejector system. So this is the diagram you can observe for a while, and see what are how the air is distributing there. As already I told that air, whatever the air is entering into the conditioned space, so that is entering through the grills. There will be inlet and outlet grills will be there. So air is entering, and again the return air has to go through the outlet grills, then it will enter into the return ducts. So this is how it is making. And to the same wall you can see the grill attachments are provided to the same wall. Inlet and outlet grills are provided here, and now the air is conditioned, or air is passed or ejected into the conditioned space. Then again it sends back by changing its direction to the outlet grill. So let us see some points regarding that. So it is commonly used in many installations. So commonly used system, that is a simple ejector system. So air is discharged into the room by inlet grills or slot diffusers or pans, which are provided at the entry of the wall. Cheap and simple in construction. Now the supply and exhaust grills, as I already explained, that they are fitted in the same wall, and the air ejector into the room with high velocity through the supply air opening. So the air is ejected here through the inlet grill with high velocity. So that is the supply air opening into the room. Now what happens is the air circulated in the space, and again that circulated air or used air which is there, that goes out through the outlet grill here. Outlet grill is provided, so that will enter. Very simple in design. And if you see the second type, that is a pan type of the structure. This is the plate pan type ejector system. So you can see here where the outlet inlet and outlet will be so two entries can be made here to maintain different directions within the room. So you can see air inlet is taking place at the top, where a pan is provided at the bottom of the air inlet, so the different directions can be taken place. Air exit can be at the down at the floor level. The air exit will be provided. So it is somewhat better than the it is relatively better for uniform distribution of air compared with the previous case simple ejector system. So it is somewhat better for uniformly distribution of air within the room. So it is an improved method of air circulation. So you can see this diagram. Next, somewhat for the same pan ejector system, it is an advanced type. It is a combined system, so where air inlet is taking place. So complete distribution throughout in the room uniformly. So somewhat it is advancement of the pan ejector system. So you can observe the diagram here. So further improvement in the air distribution system is taking place here in this combined pan ejector system. The supply and return openings are combined in one unit. Okay. Supply, you can see exit at the center here, it is moving at upwards, and inlets are taken place at the two sides combinedly. So it is making contact with throughout the room, and air is exiting again from the top. So in a one unit you can see the both inlet and outlet systems. Okay. So we'll see this requires the less capital. It means investment is very less to this combined pan ejector system. The running cost is also very low. So used for single story buildings. One building, a single story buildings are there, so it is very best suitable one. This is a combined pan ejector system, and used for both HVAC, heating, ventilation and air conditioning. So these type of combined pan ejector systems are used. So this is the third. And moving to the next system, that is a comfort draft system. So very simple in design. You can see at the bottom level of the floor, this air inlet and air outlet is placed in the same level. So up to a level of some 2.5 to 3 meters, like 2 to 2.5 meters height from the floor level. It is these passages are provided, air inlet and air outlet. If you observe here, so used where it is applicable, it means this type of air distribution is used mostly. So where we can see in the gyms or where the men is working at very hard at that place. So in that particular room, so this type of air distribution is required. So that is done with the help of this comfort draft system. So it may be used in recreation places like gymnasts, or where air should pass continuously around the occupants. So continuously it has to pass through around the occupants. Next, so it will give the better performance of the participants and removes vapors and odors produced by them. So it's best suitable as moving continuously in the room at the same height. air inlet and exit is taking place, that it removes the vapor which is on our body, sweat or odor which is present or produced by them, by ourselves also. So it is removed continuously by with the help of this comfort draft system. So air is distributed only in the occupied zone up to a height of, so used in the same direction, so to a same height, so it is limited up to a zone of up to a height of 2 meters to 2.5 meters from the floor level. So it is best suited for a particular purpose only in the gymnastics or gyms, so like that. So this comfort draft system is mostly used. Okay, so this is regarding the today's class. So hope you have understood. We'll just follow the summary. Along with that, we will see some quiz part of questions regarding this today's lesson, and questions also. We will see some important questions in this. Now just we go through this the summary part. So in this class we have studied about, so hope we have seen the continuation of the filters, air filters. Previous class we have seen two types of air filters, that is dry filters and one viscous air filter. And continuation in today's class we have seen the wet filters, electronic filters or electrostatic filters, the cyclone air filter or cyclone air cleaner, air washers also seen, and centrifugal dust collectors. So we have seen mostly regarding the air filters, and also we have seen the air distribution systems. In that we have mostly seen the important is the ejector type distribution systems, very important one. Different air distribution systems, different ejector systems also we have seen. So number of topics are covered in this today's video session. Next we focus on the some quiz point of questions. Then hope from this video class we can understand, hope you can answer that. So you can go with these questions, and then if you can answer, so you have followed the video session perfectly. So the question is, the dash filters are mostly used in industrial areas where the dust and gas or smoke is likely to be present. So what type of these filters are required? Wet filters, electronic air filters, electrostatic, and cyclone air cleaners, all of the above. So as already I told the starting of the class, wet filter, simultaneous action of both the gases as well as the dust can be removed with the help of these wet filters. So mostly used in the industrial areas. Wet filters are very effective also. Now next question, in electronic filter or electrostatic filter, the plates are charged to a DC potential of 8 to 12 kilowatts. Intermediate plates are charged to 6.5 kilowatts, 7.5, 8.5, 9.5. So answer already seen in this video session, that is 6.5 kilo voltage. Next question, if effective by remove large dust particles and also collect reusable dust to some value. Grill outlets, slot diffuser outlets, ceiling diffuser outlets, and perforated ceiling panels. So grill type. So it is effective by remove large dust particles and also collect reusable dust. So grill outlets are somewhat is helpful. And in the air distribution systems, the better air distribution system is ejector, downward system, upward system, all of the above. As you already seen one sentence regarding the downward system is very effective compared with the ejector or upward air distribution systems. Next question, air is ejected into the room with high velocity through the supply air opening, the system of the simple ejector system, fan type, downward diffuser system, comfort draft system. It means with high velocity through the supply air opening in the system. So answer is simple ejector system. Okay, so high velocity, we have seen that point also. The high velocity air distribution system, in that, and more effective one is a simple ejector system, and most used one is also simple ejector system. Next question, which system is the best suited for recreation places and gymnasiums? It is a very important question. The comfort air distribution system, I have told that it is used up to a particular level of boat to a height of 2 to 2.5 meters from the ground level or from the floor level, where mostly suitable for the gymnasiums or recreation places, where the men will produces more sweat or more odor, so it can be removed very perfectly with the help of this system. So the answer is it's a comfort draft system. Okay, so we are seeing this also the theory part, right? So this is the end of the quiz part. So hope you can answer them all of the questions. Next, the frequently asked questions which may be asked in the examinations, so we'll see the one by one. First, the question based on the wet filter. How does the wet filter works? How does the wet filter works? So explain, briefly explain it. Next, second question regarding the electrostatic air filter. It is very important question. So draw the neat sketch of electrostatic or electronic air filter and explain its working. Is also very next, cyclone air cleaner. It is also very important. Explain the principle of the cyclone air cleaner with a neat sketch. It is also very important. Describe the centrifugal dust collectors. So these out of these four, at every time they may asking the question regarding in these filters, in these air filters. These all these four are very important. It's frequently asked questions, all this. Okay, next, continuation, the air distribution system. So what is an air distribution system, and classify it, why you are using the air distribution system, as we have seen in the theory part. So this is one question. We have seen the classification also, like ejector, downward system, upward system, like that. And next important question regarding the ejector system is explain different ejector systems with a neat sketch. Okay, so this is also one question. Explain ejector systems with a neat sketch. So this is regarding today's video session. A lot of topics we have discussed, the additional equipments of the air conditioner,